Okay, so let me start with with a brief introduction of what we are trying to do with this epic. So let me start by sharing my screen. So this epic is about advisory ingestion, so ingesting OS packages. And to be more specific, we want to ingest OS package information and how they relate to advisories. And the source is the Trivy. So you might be familiar with this architectural diagram where you see the flow for advisories. And until now, we just had the GLAD advisories. So these are advisories coming from GymnasiumDB. But now we also have, we want to extend the whole system with advisories coming from the Trivy database. So there are some fundamental differences between GLAD and TrivyDB. Of course, the first one is that GymnasiumDB, so GLAD, is mainly referring to application level packages, right? So you have packages of Go, of Conan, so this kind of packages, while TrivyDB refers to application level packages, but mainly it refers to packages from distributions. So you can imagine that we have there distributions about Alpine for different versions of Alpine, of Ubuntu, of Red Hat, just name it, it's there. So there are two kinds of information that TrivyDB contains. It contains vulnerability, so advisories, raw advisories, exactly like GLAD have them. And it also contains all the affected packages. So for every distribution, there are packages, and every package has one or more advisories that they affect the package, right? So that's a bit so that you know what TrivyDB is about. So the idea is very similar. So we use the TrivyDB as an advisory source. We basically, again, use a cursor to see if what was the latest version of the TrivyDB that we have processed. Then we get that old version that we have processed the last time the advisory feeder was executed. We also download the latest TrivyDB, and then we compare those two. And we publish only the differences to the advisory processor through PubSub. Yes?
Just a quick question. So looking at the diagram there, one thing that stands out to me is that it looks like there's a single advisory feeder rather than multiple advisory feeders like we do with LicenseDB. And I just want to clarify, is that the case?
So there is a single code base, right? The project is named actually license feeder, not advisory feeder. I'm using the advisory feeder just to, to understand better what I mean. So we have one code base that we can run against licenses or against advisories. In this case, is against advisories. And every time, and what will happen basically is that we will have scheduled jobs for Trivy. So you might be familiar with the advisory feeder jobs that we have for GLAD. They run once per day, so once every 24 hours on both environments, dev and prod. Exactly the same we will do for TrivyDB. So we will have a scheduled job that will run the advisory feeder code, and as a source, we will use TrivyDB.
Perfect. Thank you.
So the advisory feeder, once it has the diff, it will send it over PubSub to the advisory processor. And the advisory processor is responsible for storing those data into the external license database. And again, we have a scheduled job for the advisory exporter that will read the data from the external license database, and it will store them into the advisory bucket, which is a public bucket. So this more or less, it's the usual flow. What I want to demonstrate today, it's basically the part that contains the advisory feeder, the advisory processor, and storing the data into the license database. So I have prototyped this part of the system. So let me scroll a bit down, and I have here another diagram. So until now, we just had one advisory processor, and that was for the GLAD source. Now we have a small change there because we use different topics depending the source. So, for instance, when we have GLAD as a source, then we send all the advisories over the GLAD topic, and then those messages are being processed by the GLAD advisory processor, which will store them into the external license DB. Now, when we use TrivyDB as a source, there are, as I mentioned before, two different things. There are the advisories, and there are the packages that we want to store. So we are going to use two different topics for this, and every topic sends the messages to a dedicated Cloud Run instance that will process that. So, for instance, for TrivyDB advisories, we have a dedicated topic that sends the data to a dedicated Cloud Run instance that will store them into a table in the database where we store TrivyDB advisories. For TrivyDB OS packages, again, we have a dedicated topic that sends the data into a dedicated Cloud Run instance that will store them in the TrivyDB package table in the license database. So yeah, this is a bit about the infrastructure, right? I don't think it makes much sense to show you the schema of the database, right? But maybe what's nice to do, at least for the demo, is show you how things are right now in the database. So let me take this. So right now I am.
Question?
Yes, of course.
I just wanted to know, has there been any changes to the existing schema as part of these changes?
So yes, we are doing changes in the existing schema, but we are basically extending the schema. We don't change anything that was there. So what we actually did was that we added two tables, the TrivyDB advisory table and the TrivyDB package table. And we also added some permissions to the advisory processor user. So the database user that is used by all these Cloud Run instances, so that user can actually write the data on those tables.
Perfect. Thank you.
No problem. So let me go back to the database. So whatever you will see here, the whole demo runs in my GCP Sandbox project, okay? So these are the two tables, TrivyDB advisory and TrivyDB package, which if I try to count right now, see how many data, it should be 0. Exactly. So for the advisory data are 0, and for the package data, oh, it's 1. Okay. Interesting. Let me make sure that it's 0 also for the package. Oops. That was me experimenting right before our call. Okay, so as you see, we have no information, right? So what I want to demo is that I would like to run the feeder, and this feeder will actually create messages for the advisories and the TrivyDB, and it will eventually end up here in the license database. Since we have no data, in theory, we should actually do a full ingestion. But the full ingestion, it's about 1 million, a bit more than 1 million PubSub messages, and it takes around 6 minutes. So I'm not going to do that. I made sure that the cursor says that we have processed a database like 2 or 3 days ago, so that we can actually check only the the differences, right? So we have less PubSub messages. So let's go into the feeder code. Not this, but this one. So this is the command that I'm going to run. I'm specifying that the source is TrivyDB. I'm specifying the two topics. And I'm specifying that this should not be a dry run. So let's see. I'm just going to say debug.
There's one thing I noticed there. Just if you are sharing this, I noticed there was a credential in the last screen that you had.
Yeah, good one. Then I will actually after this video, I'm gonna deprecate it and create a new one. Thanks for sharing that. Good catch. So let me explain a bit what is happening here. The feeder has already finished running. So what you see here is that it says that the cursor tag is this. This is actually a date. So this is 2023, September, so 5th of September. And the latest tag that exists out there is September 07. So we have 2 days differences. It will create a new database. So basically it will download the cursor tag database, and it will open it. And it will also do the same for the latest tag. And what you see here is that it says that it prints some statistics. So first statistics are about the advisories. So you see here that we have 75 advisories that have been added, and 1,416 edits on existing advisories. So in total, these are the amount of PubSub messages that the feeder sent. When it comes to packages, so OS packages, you see that we have this number of additions, 298 edits. So in total, we have this number.
That's really nice.
Yeah, I actually wanted to know how many deletes we have, but it looks like we don't get too many deletes. But it's nice and informative, I think. Now, let me go to here. And what I have here is the Cloud Run instance for packages. So let me refresh this page. The time is 11:18. Yeah, probably it's already been 2 minutes since this thing happened, because I see here from 11:16 a lot of messages with 200, right? So that means that all those PubSub messages were correctly acknowledged and inserted in the database. I'm not sure if we can see metrics, because this actually gets updated a bit slow. Yeah, we cannot see yet. So what I would say is, let's go to the database, and let me refresh. Okay, I think I need to connect again. So sorry for this. Again, this is a password that gets deprecated after an hour. So I will make sure that, so by the time the video is published, yeah, you won't be able to do much with this password.
No worries.
That's why it also timed out, right? My connection. Let's see if this will work.
Just on that, like I won't labor the point because I know you're recording, but the credential that I saw, I thought was a GitLab credential, which I don't know if it's short-lived or not.
That's indeed, it's a GitLab token credential. So that's something that I definitely need to deprecate. Okay, I think it refreshed. So let me run this. So we have this number of Trivy DB packages. right? Let's see if this maps with what we see here. Yeah, it actually maps. And now let's do the same for advisories. And you see that we have 1491, which is the same as this. So basically, this is a small demo of how it works, right? And next steps for this would be, of course, right now all this code is prototype, right? So we need to do the proper merge request and have it on dev and then on production. But for now, this thing has been validated and we know that we can do it. I think that 6 minutes for a full ingestion of 1 million entries, it's very nicely. And we haven't even optimized the advisory processor to do batch inserts, right? So I think we are quite good already. And the next step for this, it's going to be the advisory exporter, right? We need to export the advisory exporter.
Yeah, that's really cool. I was wondering when you showed me the counts there, I was wondering, is there any chance you could show me the contents of one of the rows in the database, just out of curiosity? Is that possible?
Sorry, what do you want to see exactly? I didn't get that.
Instead of showing a count, could you show me one of the rows in the database? I'm just curious.
Yeah, of course. That's a good one. Share. Actually thought that maybe it's a good idea to do it, but then I said, maybe it's not very interesting. Okay, you can see my screen, right?
Yep.
Schemas, public, tables. So let's look first on the advisory. So what you see here is the CV of the advisory, the last updated, so a timestamp, and then you actually see the actual content, right? So it's a JSON, it's a JSON-B data type for this column, and then you see the contents. And then if I go to TrivyDB package, we have an ID as a primary key, we have the distribution name, we have the distribution version, we have the package name, the advisory ID, and then we have the node value. Basically, the node value says which versions are affected.
Nice.
Okay. Then I will stop this recording. Yeah.
Sounds good.
Thanks, Philip.